Hello, brand doctor. This is Sam from exampa.net. You ask a great question here. Your main point is this. When binarization is not performed, stepwise selection will either retain or drop features entirely. Binarization allows the algorithm to drop only singular feature levels that are not significant. That's exactly correct. So that's one of the great ways that stepwise selection helps to reduce overfitting. And in the hospital readmissions example, when you have a lot of factor variables, it's a useful application. You have a valid concern when you say the problem statement says, simplify the model by removing features entirely or by combining factor levels as appropriate. It doesn't specifically say to use binarization. 2 points here. One, did you see the alternate answer at the end of the RMD file? So this doesn't use binarization. The second is that you can get clues as to what they expect you to do based on the template code that they provide. If you looked at the template file, the RMD file, you would see at the beginning that they give you the binarization code. So whenever they give you like code to reduce factor levels or do binarization, it means that somewhere in the exam they expect people to do that. So there's another problem though. The real problem is that this exam was from 2018, and that was 2 years ago. So the grading criteria has changed. As you notice from like hospital readmissions and especially the student success project statement, is that not all of the questions were reasonable with respect to time constraints. Really, they take too long. The questions probably weren't even timed when they designed them. And so if you were to add those questions to a current exam PA, it would just cause a lot of confusion, and I don't think anyone would be able to answer them correctly. So that being said, here's a quick walkthrough of the alternate solution. And so you can reproduce this yourself if you go to the bottom of the SOA's RMD template file. So now this is a really long solution. It took me quite a few minutes even just to run all the code to get down here. So they say this section presents an alternative approach. It's based on using hypothesis tests to sequentially remove features. It begins by rerunning the model, and et cetera, et cetera. So basically, they just fit multiple models, each using different combinations of the factor variables. Sometimes they combine levels together, and sometimes they leave them separately. Yeah. So to spare you a lot of the time, I'll just go ahead and just show you one example. So you could look at the race example, the race variable. So here's the first model, and you can see there's different features for race Hispanic, race others, race white, right? And if you look at the p-values, you see that they're all quite large, indicating that that variable is not predictive, that the null hypothesis that that variable is predictive is probably false. You can go ahead and remove those. So if you just used binarization, of course, it would do that for you. You could also just manually set those levels to be just binary outcome, either black or non-black, because those are the two most predictive levels. So if you look at the SOA's code, they use this really long-winded method of doing that, where they use these map values functions, etc. There's actually a faster way you can do that. So you can just use what's called this mutate function, which you can find out in the study guide, which I'll link below. But there's a long story short, simpler way of doing that. Here's the model here. When you run this, you can see that the p-value is more significant. And if you look at the AIC, see this is 33833. Compare that to the other AIC 33386. It's better. So if you join the online course, you'll get access to newer practice exams that are based on the current format. You won't have this difficulty. You can also see the full video solution to the hospital readmissions exam.